Okay, here in the second part of section 4.5, we're going to talk about how to graph tangent and cotangent. And so lots of information to get through first, and then we'll get to 4 example problems. And so if you'll take a look here, we've got 2 nice pictures of tangent, and the reason I needed 2 is because this first one does not do a good job of showing you that tangent has vertical asymptotes in it, but the second picture on the right does a really good job of showing the vertical asymptotes. And so what I'm going to do here on this picture is I'm actually going to draw in these vertical asymptotes at negative pi over 2 and pi over 2. And so essentially what we're looking at here is one period of the tangent graph, and here we're looking at multiple periods of the tangent graph. And so the first question that we want to answer here is, what is the period of the tangent function? Well, if the first asymptote on the right-hand side occurs at pi over 2, and the second one on the left occurs at negative pi over 2, then to find the distance between those, we just need to subtract. And so this ends up being pi over 2 plus pi over 2, which of course is pi. And so the period of the tangent function is pi. And notice that that is a major difference from the 4 graphs that we've already talked about here in trigonometry. And so pi is the period of tangent. Now, the domain is all real numbers, but I've got a blank there because it's not actually all real numbers. You've got to exclude, so I'm going to say here, except all of the odd multiples of pi over 2. And we talked about what that means when we discussed the secant graph. So odd multiples of pi over 2. So that would be 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. 19 pi over 2, and then every negative variation of that as well. Okay, the range of the tangent function is negative infinity to infinity. And so, again, this picture doesn't do a great job, but there are really arrows here that should go all the way down and all the way up. Okay, vertical asymptotes occur at the beginning and the end of every period. And so that's what I'm going to put in this blank. They occur at the beginning and the end of the period. And so every period is going to start and stop with a vertical asymptote. Now, there is an X-Intercept for every period of the tangent function, and it happens right here, which is exactly halfway through the period. And so here I'm going to say halfway through the period. That's when you're going to have an X-intercept, and I'm probably just going to call it what we've been calling it, which is a 0. Tangent has some symmetry. It is symmetric to the origin, which means that it is odd. And then it has some very easy to identify y-coordinates as well. And so I'm going to zoom in here just a little bit so that you can see where these y-coordinates are. And so you can see that there's one here at -1, which is a really easy to identify point, and then another one here at +1, and those occur 1/4 of the way and 3/4 of the way through the function. And so that's what we're going to put here in our blank, is that this occurs 1/4 and 3/4 through the period. And so what I'm trying to line up for you here is that tangent has an order of points, just like sine, cosine, and secant and cosecant had. And so if we can remember what the order of the 5 points are, that's going to make it very easy to graph. And we'll summarize that here in just a minute. Okay, for the cotangent function, a lot of things are going to be pretty similar here to the tangent function, but there are going to be a couple of minor changes to the information here. Now, this is a picture that you see below here of multiple periods of the cotangent graph, but if you zero in on one of them, so for example, maybe the one here between 0 and pi, you can see that the period is pi, just like for tangent. And so we've got 4 graphs that have a period of 2 pi, that would be sine, cosine, secant, and cosecant, and now 2 functions who have a period of pi, that would be tangent and cotangent. Now, the domain is all real numbers except for where you have these vertical asymptotes come into play. and that's going to be every integer multiple of pi. And so we've talked about how that works. Integer multiple of pi, that has to be excluded from the domain because of the vertical asymptotes. The range, just like tangent, is also going to be negative infinity to infinity. Just like tangent, every period is going to begin and end with a vertical asymptote. So I'm going to put here begin and end the period. And then the x-intercept, just like tangent, comes halfway through the period. So halfway through the period, you're going to have that x-intercept, or probably more commonly called by me, a 0. Now, there is some symmetry to the cotangent function. It is also symmetric to the origin, and therefore it is also odd. Okay, and then the y-coordinates. The y-coordinates are going to be, again, a quarter of the way and 3/4 of the way through the period. But one thing that I failed to mention for the tangent function that I'm going to mention here for cotangent is that for cotangent, the y-coordinates are decreasing. And so this is a decreasing function, whereas tangent is an increasing function. And so what you're going to hear me say is that the y-coordinates go, for example, here from high to low for the cotangent graph. For the tangent graph, it would be the reverse of that. They would go from the low y-coordinate to the high y-coordinate. And so that's the terminology that I'm going to use just to indicate the increasing and decreasing behavior of these functions. Okay, now obviously so far in the notes we've been discussing the parent functions of tangent and cotangent, but we're not always going to be graphing the parent functions. We're going to be graphing different variations of tangent and cotangent. And so here is just sort of a step-by-step synopsis of what we're going to do in order to graph these. And so starting with tangent here in letter A, if I have y equals a tangent of bx minus c, the first thing I'm going to do is find the first asymptote. That's going to be the starting point of your graph on the x-axis, much like the phase shift was the starting place for sine, cosine, secant, and cosecant. Now we're talking about asymptote as opposed to phase shift. And how we're going to do that is by taking the parentheses bx minus c and setting it equal to negative pi over 2 and then solving for x. That's going to give you your starting x value. Now once you have that starting x value, we're still going to count by the x increment to get successive values of x. The only difference here between tangent, cotangent, and the other four is that to find the period, we're going to need a slightly different formula. And so the period, to find the period for tangent and cotangent, instead of 2 pi over b, it's going to be 1 pi over b, and that has everything to do with the fact that the period of the parent graphs of tangent and cotangent are just pi and not 2 pi like the other four graphs. Okay, once we have the period, the x increment, the starting point, or the first asymptote, then the order of the points are going to be asymptote, the y-coordinate, but more specifically the low y-coordinate, because remember tangent is an increasing graph from left to right, the 0, then the high y-coordinate, and then finally another asymptote. For cotangent, very similar process. The only difference is that the first asymptote is found by taking the parentheses and setting them equal to 0 and solving for x, but you're still going to use period is equal to pi over b in order to find the period, and then in order to do that you need to find the x increment so that you know what to count by. And then the order of points is very similar, except the y-coordinates are flipped. You're going to have the high y-coordinate first and then the low y-coordinate on your cotangent graph, since it's a decreasing function.